Hi, I'm Travis Connor, and this is my Physics 2212 Lab 2 about lines of charge. This lab involves using the results from Lab 1 to produce a more refined coding model. The purpose of this was to determine approximately how much excess charge is on one piece of charged clear tape using line charges. There are a few fundamental principles used in this lab. The first was the assumption that each piece of tape had an equal distributed charge. The second was that the pieces of tape could be modeled as line charges. In this experiment, I also used Newton's second law and Coulomb's law, as well as the force equation. I also used the approximate dimensions of an atom. The main results from Lab 1 are as follows. Repulsion occurred when the pieces of tape were 1.9 centimeters apart. Identified that the tape pieces were both positively charged and that the charge on each piece was, as you can see on here. Also, each piece of tape was deficient by the number on the screen. The main result from Lab 2 was that the magnitude of electric force was 2.06 times 10 to the negative 3 coulombs. Further assumptions I made were that air resistance was negligible and that the tape could be treated as a point charge. Additionally, I assumed each piece of tape had the same amount of charge evenly distributed. I modeled each piece of tape as a line charge to observe the electric force interactions on a macro scale. Now moving on to the experiment. The system in this experiment were tapes A and B and the surroundings for everything else in the lab room. The initial conditions were two pieces of neutral tape approximately the same length and two pieces of tape attached to the table. And then the process for this experiment was to tear off the pieces of tape and then hold them up next to each other and observe the electric force. I observed during this experiment that the two U-tapes repelled from each other and that the U-tape was attracted to a neutral object such as my hand and the U-tape was attracted to a negatively charged pen. I concluded from the experiment that both U-tapes were positively charged and exerted a force against one another, and that each tape lost electrons in the charging process. My data from Lab 1 can be seen on the left. The number of electrons lost was found to be 5.67 times 10 to the 10th power, and the number of atoms on the tape was 2.482 times 10 to the 17th. For my coding, it can be broken down into 4 parts. The first part, constants, included data about the tape and the charge of an electron. The next part of the code used the electric field function to determine the charge E. After that, I found the electric force using the electric field. Lastly, I created arrows to display these interactions. Here the results of the code can be seen, with the electric force and gravitational force being equal to one another. Moving on to the discussion, the charge of the tapes as determined in this lab was 2.06 times 10 to the negative 3 coulombs. In my model, there were some discrepancies, which were that the pieces of tape were not true line charges and also that the charges on each tape were likely not equal. Also, the computational model serves as a perfect model, meaning it does not completely represent the tape experiment in the real world. My possible source of error were differences in size of tape used, loss of charge on the pieces of tape during the experiment, and the possible incorrect measurement of the distance between the tape pieces. To answer the what if question, Lab 1 had a charge of 9.09 times 10 to the negative 9 coulombs, while Lab 2 had a charge of 2.06 times 10 to the negative 3 coulombs, showing a large difference. And to answer the why question, these estimates differ because they are modeled very differently. Lab 2 used a more distributed force, while Lab 1 was very concentrated. Additionally, the line charge model is closer to the true value. To conclude, everyday objects can be used to model electric forces and identify electric change. Newton's laws apply to electric charges, and careful analysis can allow us to determine electric forces, which allows us to model them accurately. Additionally, from this experiment, it can be seen that by modeling the tape as line charges, we can get a more accurate representation of the electric force between the two tapes compared to Lab 1, where we treated them as point charges, resulting in a fairly inaccurate result.